Okay, we're doing properties of vectors. There's commutative property, associative property, and distributive property when adding or subtracting vectors. Adding a zero vector doesn't affect anything. And then associative law of scalars. That's when multiplying a number with only magnitude to it, no direction, by a vector. Okay? And we're going to go over a couple questions like that. And right now we're just going over simplifying these, making sure we know how to use these rules in algebraic models. So we go to the next page. Example 1. They give us this question here. Simplify the following. Okay? So 3 times 2 vector A plus vector B plus vector C minus vector A plus 3B minus 2C. Okay. So there's a couple of the laws, and I'll try to remember them as we go. The first one we're actually going to deal with here is, first we'll try to collect our like terms. So we'd use an associative property in terms of adding. When we're doing bed mass, what do we deal with first? Anyone remember? Yeah, brackets. So we talk about the brackets. Can I simplify these brackets? Are any of these, could be called variables, but in our case vectors, are any of them the same? No. I cannot add any of these vectors together. They're stuck the way they are. So the next thing I do is I move to exponents, which we don't have any, then multiplication and division. Well, this 3 is technically multiplied by every single number in the bracket. Just like this negative, what number could I kind of say is there, or assume to be there? 1. We could assume there's a negative 1, needs to be multiplied by each of the terms inside this bracket also. So we're going to simplify that by moving that number in. We'll then get 6 vector A plus 3B plus 3C. And then we multiply by negative 1, gives us negative vector A minus 3 vector B plus 2 vector C. Well, now we have some like terms. We have our A vectors, B vectors, and our C vectors. Let's simplify them. 6A minus A. Anyone know what that's going to be? Equivalent to 5A. Okay. Remember, we're adding vectors together. The vector A is going to be parallel to itself, right? And if it's going the opposite direction, if we start at A, we go up it 6 times, and then back 1, we're only the equivalent of going up 5 times. B, 3B and negative 3B, what does that do? Cancel out, becomes a 0 vector. We could say, we could do that just so we can use that law of adding 0 vectors. And 3C plus 2C is the equivalent of 5C, yeah. Very simple type math. Well, we add a 0 vector, it doesn't do anything, so 5A and 5C. Okay. Now, just to quickly look, do they want us to factor that? Yeah, we can. We can factor this. They didn't really say. They said expand and simplify, which usually means there is no factoring involved. But if you felt for your purpose you wanted to factor it out, you're right. This could also be written as a scalar of 5, and we're just looking at vector A plus vector C. And then multiply by scalar 5. But they didn't ask for that, so we didn't have to do that. Okay? That's the first one. The second one has quite a few different examples. What we'll do for the second one is we'll go through the hardest one. Since this is a relatively easy topic, we'll go through the most complex one. What they've done is they've given us values. So it says vector x is equal to, and we're going to get into I, j, k a little later. There you go. Vector x, example 2. Vector x is equal to 3i. I stands for a unit vector along the x-axis, which we'll talk about tomorrow. J, good. If any of you guys remember it, j is a unit vector along the y-axis, and k is a unit vector along the z-axis. That's 3-dimensional. We'll talk about it a little later. That's represented by vector x. Vector y is the equivalent of j minus 5k. And vector z, I assume, is the next one. Yeah, is negative I, negative j, plus 4k. Now the reason they're using ijk is because in the next couple lessons we're going to get into what they represent. They technically represent unit vectors in the third dimension when we're using x, y, z along the Cartesian plane. Really, we just need to know how to simplify it. So the most difficult question they've given us then, after they've given us these parameters, is C. And C says to positive vector x, subtract the scalar of 2 or negative 2y plus 3 vector z. Well, we know we're going to be able to do this, so what we're going to do, that's all there is to it. We're going to plug in values for x, y, and z, which I'm sure most of you guys already knew to do. So for vector x, we replace it with 3i minus 4j plus 1k. I put the arrow above because it is a vector, it has direction. Scalar of 2, y is j minus 5k, and plus scalar of 3, z is negative I, negative j plus 4k. Need to make sure I call these vectors, okay? We then use our distributive property. Okay, so the 2 will be multiplied by those to those, and the 3 by all of those in there. I can essentially drop these brackets, so I get 3i minus 4j plus k. I'll put the arrows in at the end. Minus 2j plus 10k plus, sorry, not plus, 3 times negative 1, negative 3i, negative 3j, plus 12k. And they're all vectors. So we're going to collect our like terms after. Put all our i's together. There are only 2 of them. There are 3 j's and there are 3 k's. Put them all together. I becomes 0 vector. J, negative 4 minus 2. Yeah, negative 6, and then negative 6 minus 3. Negative 9j. And K, 10 plus 1 is 11, plus 12 is 23. Oops. When we add the 0 vector, it does nothing, so we get 9. That's supposed to be, let's fix that. Oh gosh. 9 vector j plus 23 vector k. Let's just look at both pages. So that's it. We simplified all those vectors using all of the properties and rules they had previously given us.